Dear friends, now I am going to speak about quantitative analysis that are adopted by media researchers. In media research, we have two categories of research. One is called quantitative, another is called qualitative. There is a huge difference between the two because media research does not always talk in terms of empiricism. Some are subjective, some are objective. Now, with this little introduction to quantitative analysis, which is also an introduction to media research, I hope I will be able to make certain issues and certain points clear for the audience. There are many approaches to knowledge. The basic assumption in media research is to acquire knowledge, and the aim of research is to search for truth. It is research in the real sense of the term. There are many approaches to knowledge as described by many scholars. One approach is called as tenacity, and the second approach is called as intuition, and the third one is authority, and the last one is scientific approach. These are the classifications made by a well-known researcher, social science researcher, Kerlinger. What is the method of tenacity? It involves the use of logic that something is real or true because it has always been real or true. This assertion is that nothing changes, like what was good, what was bad is good and is bad. So, this kind of argument normally is not acceptable in scientific research. In the method of intuition, a person decides that something is true because it is self-evident or it stands to reason. Some advertisers do not believe in the effectiveness of other modes of communication because they don't want to test, since the product itself is of some quality and it is self-evident that it advertises itself. So, for them, advertising on different media for a long time would be a waste of money and waste of time. So, here the emphasis is on the source of information, not on the methods of information collection. And the last one which we have been talking of is of the scientific method. The scientific method will be discussed a little bit later. There is another classification of acquiring knowledge. It is almost the same like the earlier one. It is the classification of authoritarian mode, the mystical mode, and the rationalistic mode besides the scientific mode. The difference among all the four modes of approach to knowledge is the manner in which the producer of knowledge, the procedure of knowledge production, and the effects of knowledge are taken into account. In the authoritarian approach, normally knowledge is collected from the people who are known as an authority or producers of knowledge. For example, there can be an oracle in a tribal group, a priest in a religious society, or a king in a monarchical society, and scientists or technocrats in a scientific or technocratic society. Different societies have different approaches to knowledge, rather different sources to knowledge. Take, for example, the mystical mode, the second one. Here, knowledge is collected from prophets, divines, gods, mediums, and other supernatural powers. In a way, the mystical mode resembles the authoritarian mode. The mystical mode is related with supernatural signs and psychophysical makeup of the persons. It mainly depends upon the practice of rituals and ceremonies. When a person is not in a good shape of mind, when he is helpless or distressed or intoxicated, there is every chance that he is likely to accept the knowledge produced by the mystical mode practitioners. Then let us go to the rationalistic mode. The rationalistic mode stresses on the procedures by which explanations are given. In other words, it uses the rules of logic. The formal logical procedure can be seen in its structure. For example, we have a syllogism. The syllogism can be like this: all A are equal to B, all B are equal to C, therefore all A are equal to C. The first two statements of the syllogism are called as premises, and the last one is known as the conclusion. The statement at the end, all A are equal to C, is logical, can be accepted, but all explanations cannot come under this category and are not verifiable through the syllogical procedures. Often, the users of the rationalistic mode accept the logical procedures of so-called syllogism. Social scientists normally do not accept the knowledge produced by the first three categories. They want empirical evidence to understand a particular phenomenon or particular phenomena. Let us remember here, in media research, like social science research, we have a research parlance or a research jargon. So we will be using the jargon repeatedly so that the people who are involved in receiving the research results will be able to understand them properly. Science demands exactness. Science requires plausible and clear explanations. So if you are doing scientific research, if you are accepting the scientific mode of research, then you have to identify 4 important operations that are included in the scientific approach. What are these 4 operations? Number 1, demonstration of covariance. Number 2, elimination of spurious relation. The third one is the establishment of a time order, or what we call as sequencing or sequence. And lastly, the fourth one, it is theorization. These can be considered as important because we have to use them to draw what we call as causal inferences. What is covariation? Covariation means that 2 or more phenomena vary together. For example, take 2 phenomena, education and income. If education varies, the level of income of a person should also vary. Then only there is covariation. We presume that higher the education level, higher will be the income level. So, education level is directly associated with the level of income of a person. If there is a change in the level of education if it does not prompt any change in the level of income. We can simply say that education does not co-vary with income. When we take up scientific research, the concept of covariation is described in terms of correlations or associations. A correlation between two phenomena on its own can be the basis for causal interpretations. Let us go to the second operation. The second operation is the elimination of spurious relations. It means we have to demonstrate that the observed covariation is natural but not spurious. In other words, it is defined as a correlation between two phenomena that does not require any explanation by a third factor. It is the link between the two phenomena which could be inherent and observed. Covariation does not happen just like that. It means it is not accidental. It needs the researcher to know what exactly is happening. I will give you an example. Imagine that there is a fire accident. If the fire accident is to be related to other factors, normally, we say that the amount of damage is related to the size of the fire, and also the number of firemen required to extinguish the fire is related to the size of the fire. In other words, the size of the fire is related to the number of firemen required, or the number of firemen required is related to the size of the fire. The damage in the fire and the number of firemen required have no relation at all. So this is what we call as, if we start talking about the number of firemen required because of the damage in the fire, it is a spurious relation. Actually, the natural relation is the size of the fire and the number of firemen required. The third one is the time order. See, the time order is to establish the sequence, which phenomenon occurs first, which phenomenon occurs later. So there is a sequential correlation between two phenomena. For example, urbanization and political participation. Here we have to establish that there is a relationship between urbanization and political participation. Which one happens first? Normally we have to say urbanization happens first and then political participation takes place. The cause is the urbanization. So the time order or the sequence is first the urbanization and then the political participation of the people. The last operation is known as theorization. What is a theory? What is the job of a theory? A theory is expected to interpret covariation. And in social sciences, theory is considered as a thought process or conceptualization. It is little bit different from empirical observations. Science emphasizes general explanations. Explanations are categorized into deductive and probabilistic. This classification is based on the types of generalization that explanations use. What is a deductive explanation and what are its characteristics? Let me tell you that a deductive explanation wants, number one, a universal generalization, number two, a statement of conditions under which the generalizations appear to be true. Thirdly, it has to have an event to be explained. We call it as explicandum. And lastly, the rules of logic. One more example for deductive explanation can be the law of gravitation. The Earth's gravitational pull is a fine example which will say that it is true in all the places and all the times, past, present, and future. A well-developed social science can generate deductive explanations as it happens in the natural sciences. In natural sciences, deductive explanations are drawn through manipulation and control of experiment. Whereas in social sciences, it is very difficult to manipulate and experiment. Then let us move to probabilistic explanations. What is a probabilistic explanation? It is an expression of an arithmetical ratio between the phenomena being tested or generalization that explain certain tendencies. To be precise, the generalization offers evidence for the phenomena as the explanations cannot be deducted from the generalization. In this kind of explanation, we cannot say that all A are equal to C. Probabilistic explanations are considered to be very weak in comparison to deductive explanations. Why does it happen like this? It is simply because probabilistic explanations have a limited predictive ability. We have a third category called Western school of thought. It is a German school of thought which does not always believe in empirical evidence. It also stresses on qualitative assessment of the relationship between two or more phenomena. When you talk of quantitative analysis, you must also understand that there are certain elements of research and we have to know them very clearly so that we will be able to analyze them in terms of numerals. What are the main elements of research? Please remember that media research has borrowed heavily from social science research. In fact, there is not much difference between social science research and media research. In social sciences, we talk of research elements like concepts, assumptions, definitions, variables, and also we talk of hypothesis. There is a little bit of difference between hypothesis and research questions. Normally, we use research questions in qualitative analysis, hypothesis in quantitative analysis. But it doesn't mean that both of them cannot be used in both. There is always a possibility that we can use both research questions and hypothesis in qualitative as well as quantitative analysis. Let us first take up the element of concept. Concepts represent different phenomena. A concept can be simple, it can also be abstract. We use language to define and describe concepts. For example, there can be a concept of power. It can also be political power. Democracy is a concept. Globalization is a concept. Violence is a concept. Human right can also be a concept to deal with. Of course, there is a catch here. The catch is each discipline, each subject has its own concepts to deal with. Concepts are having the ability to transfer information as images of experiences in the real world. When it comes to a choice between two identical concepts representing the same observation, we have to choose the one which is more useful than the other. In the case of empirical phenomena, the abstractions may not work too much. I can give an example of a concept called weight here. Various physical objects have the quality or the trait of weight. Objects are either heavy or light. Income can also be one more concept which can be classified or which can take many values. So status, role, poverty, so many other concepts are being used in media research. When we generalize concepts, these concepts help in the construction of assumption. A concept may be related to other concepts. In other words, when two or more concepts are brought together, in the process may generate assumptions. A number of assumptions, when combined, can form what we call as a deductive proposition. And a deductive proposition may in return generate formal theories. So we have to understand that concepts, assumptions and deductions all contribute to the generation of formal theories. Concepts are normally drawn from perceptions and sense impressions. We call this as abstraction. Abstraction and generalization are sense impressions, then the descriptive aspect of it is the responsibility of the researcher. When we are processing the concepts or what we call as organizing and isolating objects or properties of objects, it leads to what we call as a scientific evaluation of the research concept. And conceptualization leads to definitions. In between, I would like to mention that we also use another technical term called construct. Is there any difference between a concept and a construct? No, not much, but there is a slight difference. A construct is a concept that has three unique characteristics. Number one, it is abstract. Number two, because it is abstract, it cannot be observed directly. And lastly, it is designed for certain research purposes. Let me go back to definition. In definition, we have two types of definitions. One is conceptual definition, the other one is operational definition. Let me talk about conceptual definition first. I can give an example of political violence. The conceptual definition of political violence can be aggressive behavior toward political roles of people. The definition can also be different because each person may have his own perception and he may describe it differently. Simpler concepts are used to define other concepts in media research. Various concepts can be employed to describe other concepts. A conceptual definition is neither true nor false. For example, I can give the concept of power. It can be defined as a deviation from equality. We cannot reject this kind of description as it is not false. Conceptual definitions have two characteristics. Number one, the concept to be defined is always explained or described by other concepts, but not by itself. Secondly, positive conceptual definitions are always preferred to negative definitions. For example, we cannot explain the operational definition that intelligence is colorless, odorless, weightless, shapeless. Okay. Operational definitions bridge the gap between theoretical conceptual level and the observation empirical level. So, the meaning of every concept, when it is specific, then it is easy to understand. The operational definitions are the definitions of the researcher of some of the terms or concepts used by the researcher himself. You take the example of a term called solubility. A substance, for example, salt, when placed in water, dissolves itself. The structure of an operational definition can be like this. If a stimulus is applied to an object and if it produces certain reaction, then we say the object has a property. This property is known as the operational definition. There are two issues related to definitions. One is the degree of congruity between conceptual definitions and operational definitions. Secondly, some of the concepts that are used in research are not easily operationally definable. I can give you some examples of concepts like beauty, ego, or even Oedipus complex. It means the congruence between conceptual and operational definitions can be measured by employing the tests of validity. Secondly, there are some concepts that cannot be easily defined operationally. I can give you some examples like the concepts of beauty, Oedipus complex, or ego, and others. The congruity between conceptual and operational definitions can be measured by employing validity tests. When some concepts lack operational definitions, these are known as hypothetical concepts. Let us move to the next one, variables. What is a variable? The definition is that a variable is a phenomenon that varies mostly on its own and also because of other phenomena. It is described as, within quotes, an empirically applicable concept that takes on two or more values. I have already explained some of the concepts which are used in media research, like political participation, or we can even take up social class. Social status can also be a concept which can have 5 values: lower middle, upper middle, and upper class. But some variables will carry only 2 values, sometimes 3 values. For example, sex can have only 2 values, male and female, for the purpose of research. Most of the variables that are employed in media research are not necessarily be dichotomous. They may have more than 2 values. We have normally 3 types of values used in media research. These 3 variables are known as independent variable, control variable, and dependent variable. An independent variable is also called as predictor variable, while the control variable is known as test variable. Lastly, the dependent variable is called as criterion variable. We have also got intervening variable, precedent variable, and antecedent variable to signify these 3 categories. The variable that the researcher wants to describe is known as dependent variable. The variables that explain the phenomena are known as independent variables. We can straight away say that an independent variable is the cause of a dependent variable, and the dependent variable is the expected result of an independent variable. In other words, an independent variable and a dependent variable represent the cause and effect relationship. The third one, which we have mentioned, the control variable, is the one which controls the relationship between the independent variable and the dependent variable. I have already given the example of the fire. The size of the fire is considered to be the control variable between the number of firemen required and the damage caused by the fire accident. Let us go to hypothesis. What is a hypothesis? A hypothesis is a tentative answer to a research question or a problem. A hypothesis can be explained in terms of the relationship between an independent variable and a dependent variable. Most of the hypotheses are tentative because we have to identify and examine the exactness or the truthfulness of the hypothesis, because this can be done only after empirically testing the hypothesis. A hypothesis is always formulated by the researcher because of his assumptions. When a hypothesis is tested, either it can be accepted or it can be rejected. There are many sources for formulating a hypothesis. It can be drawn from a theory, it can be from one's own observation, it can be just because the researcher has got an intuition, or a combination of any two or three of these. The common sources for hypothesis are limitless. A formal theory can also produce a number of hypotheses, and there are certain characteristics of a good hypothesis. What are these characteristics? Number one, a hypothesis must be very clear. Clarity comes from definitions, particularly the operational definitions. Secondly, most of the scientific hypotheses, or all of scientific hypotheses, are value neutral. Thirdly, a hypothesis must be specific. And lastly, a hypothesis must be researchable. So, when we conduct a quantitative analysis, then we frame the hypothesis and apply statistical tests. I will be talking about these testing of hypothesis aspects little later. Let me tell you that there are many types of hypotheses, but normally we use research hypothesis and null hypothesis in media research when we apply certain statistical methods. Now, I have to talk to you about the quality of data which we collect through different means. The quality of data is responsible for the use of statistical tests. We call, certain practices which are used to measure the quality of data or to signify the level of data as levels of measurements. What is a measurement? This question is to be answered. It is a procedure to assign numerals to properties, objects, or events by the researcher according to certain set rules. The numerals, I am deliberately using the word numeral to signify its utility. The numerals are used for comparison, evaluation, and the assessment of relations among or between different properties or variables. A numeral is a symbol of the form 1, 2, 3 Arabic. It can also be 1, 2, 3 Roman. We must know here that it has no quantitative meaning unless a meaning is given. 1 is 1 only, 2 is 2 only, 3 is 3 only. When we say a particular student is number 1 in the class, then it gives a meaning as to the achievement of that student. You can also see that cricket players or football players wearing shirts with numbers. Numbers are used here to label objects, events, and individuals. Numerals that are given quantitative meanings will become numbers. The numbers facilitate the employment of statistical and mathematical tests for description, explanation, and prediction. When we use the term assignment in terms of levels of measurement, it has a meaning. The meaning is mapping. As we have already stated, numerals or numbers are mapped onto objects or events. There are rules that prescribe the procedure of assigning the numerals to objects or events. Rules are important to the measurement procedure because they decide the quality of measurement. Poor rules will end up in a bad measurement. Rules should always reflect reality. Measurement becomes useful when the measurement procedure is related to reality. We describe that the measurement procedure and the number system should be isomorphic to reality. What is isomorphism? Isomorphism is similarity or identity of structure. It means the numerical system should be similar in structure to the structure of events or objects that are being measured. The need for isomorphism between the numerical system and the empirical properties will lead to different levels of measurement. As already stated, there are 4 levels of measurement: nominal, ordinal, interval, and ratio. The nominal level is considered to be the weakest level of measurement. Here, the numbers are symbols used to classify the objects. For example, numbers 1 and 2 can be given to classify the population into males and females. Males can have number 1 and females can have number 2. It can be more than 2 also. When a set of objects are categorized into exhaustive categories, that is, if they include all the objects or individuals or events, and if they are mutually exclusive, each category is identified with a different symbol, then we say that the level of measurement is nominal. Mutually exclusive, in other words, means that no object is included in more than one category. In terms of mathematical explanations, the basic feature of nominal level measurement is that the properties of objects in one category are equal to each other. However, it doesn't go beyond this description. Equivalence has got 3 properties, which are reflexivity, symmetry, and transitivity. Reflexivity means that every object in one of the categories is equal to itself. I can give an instance here. Take the example of a particular religion, maybe the Hindus. A is equal to A in this category because all of them are Hindus. Symmetry is the relationship when if A is equal to B, then B is equal to A. Transitivity is the relationship when if A is equal to B and B is equal to C, then A is equal to C. These elements operate within each category but not between 2 categories. In media researcher, when some properties are not only classificatory but also display some kind of relationship like higher than, greater than, then a particular symbol, greater than symbol, is used for this purpose. For example, we can say Indians are more democratic than Chinese. If the relation greater than is common for all pairs of objects, if it provides a rank order, then we call this as ordinal level of measurement. Here, the equivalence relation exists among the members of the same category, but the greater than relation prevails between any pair of categories or classes. The greater than relation is irreflexive, asymmetrical, and transitive. If reflexivity is an element of logic, then it is false, because for any A is greater than A, because we take two A's together. It can only be A should be equal to A but not greater than A. Asymmetry means that if A is greater than B, then B is greater than A, which cannot happen. Transitivity is that if A is greater than B and B is greater than C, then automatically A is greater than C. This ordinal level of measurement has the rank order but does not change the information that it gives. The numbers given to the objects which are ranked are known as rank values. The greatest or the smallest is assigned 1, the next in size 2, and it goes on. The numbers reflect the rank order, nothing more. However, we should not presume that because the numbers are equally spaced, the properties they represent are also equally spaced. Let me go to the next level of measurement. A part of greater than relation, if an exact distance between each of the objects is known, and if the distance between these two objects is constant, we can simply say that the measurement level is interval. For example, Krishna is taller than Ram. He is taller than Ram by 2 inches. For quantitative comparisons, we have to have a unit of measurement. When we establish a unit of measurement, we say that the interval level of measurement is true. Variables measured at the interval level are height, temperature, time, IQ, and income. There are differences between the objects identified here because they are isomorphic to the structure of arithmetic. The formal properties at the interval level are uniqueness. The uniqueness can be described in such terms. For example, if A and B represent real numbers, then A plus B and A into B represent only one real number. That is, 2 plus 2 is equal to 2 into 2. The second one is symmetry. If A is equal to B, then B is equal to A. The third characteristic is commutation. If A and B stand for real numbers, then A plus B is equal to B plus A, and A into B is equal to B into A. Then comes the property of substitution. If A is equal to B is equal to A plus C is equal to D, then B plus C will be equal to D. And if A and E is equal to B and AC is equal to D, then BC is equal to D. This is how we explain the substitution. The last one is association. If A, B and C are real numbers, then A plus B plus C is equal to A plus B plus C, and A B into C will be A into BC. Then we go to the ratio level. properties that have a natural 0 point are known to be measurable on the ratio level. They include weight, time, length, and area that have a natural 0 point. The interval and ratio levels are similar and the same rules are applied to both, but except one. In the case of ratio level measurement, the measurement begins with a 0 point. In the case of interval level, the measurement begins with an arbitrary point. The logical properties of the ratio level, which are operationally achieved, are equivalence, greater than, known distance between any two numbers, and a true 0 point. Variables which are amenable to ratio measurement are also amenable at nominal, ordinal, and interval levels. In other words, a property which can be measured at a higher level can also be measured at a lower level. But the other way around is not possible, in the sense that what is measured at the lower level cannot be measured at the higher level. We must remember here that mathematics and statistics are languages without content. They carry numbers but do not bother to explain whether these numbers represent the subject matter of research. But when you use them in the context, they will give meanings.